Suppose we roll n dice and keep the highest one. What is the distribution of values? Alright, so this question actually has a fairly simple solution. And so when we mean the distribution of values, we actually just mean the probability that the highest number rolled is k. So really all we want to find is the probability that the maximum roll, we'll call it x, is equal to k for some k between 1 and 6. So for k is equal to 1, 2, all the way up to 6. Where in this case, x is the highest roll. So x is equal to highest roll. Okay, so all we want to find is the probability that x is equal to k for all these k's. And so instead of that, let's try to find the probability that x is less than or equal to k. You'll see why soon. But we'll try to find the probability that x is less than or equal to k for k is equal to 1, 2, all the way up to 6. Okay, and so this is actually just, so the probability that x is less than or equal to k, it's just for a single dice, you can think about it, it's just k over 6. Since there's 6 possibilities in total, and in k of those 6 possibilities will lead to a roll that is less than or equal to k. That's for a single dice, and so for n dice, this is just k over 6 raised to the power of n. And we can actually also just raise the numerator and denominator by the power of n, so this is just equal to k to the n over 6 to the n. Okay, and now let's try to find, so actually, yeah, I'll write down an equation. I'll explain it after. So the probability that x is equal to k is the probability that x is less than or equal to k minus the probability that x is less than or equal to k minus 1. And why is this? Well, just having x less than or equal to k doesn't actually guarantee that one of the tosses will be k. Since, that the highest toss, x represents the highest toss, but in order for x to be equal to k, we want at least one of the tosses to be k. So we're here, like this event is obviously the probability that the highest toss is less than or equal to k, but we don't want all the tosses to be less than or equal to k minus 1, since then like this wouldn't be, the highest toss wouldn't actually be k. And so yeah, this is why this equality holds. And here that this is actually given by the same formula. So this right here is just k minus 1 to the n over 6 to the n by the same logic. And so this is actually just given by k to the n over 6 to the n minus k minus 1 to the n over 6 to the n. And we can take these under the same, just add them, and this is equal to k to the n minus k minus 1 to the n over 6 to the n. Alright, so we found our expression for the probability that x is equal to k for any k from 1 to 6. And so let's try an example. For example, if we want to find the probability that if we roll 10 dice, so if you have 10 dice rolls, we want to find the probability that the highest roll is 4. So probability that the highest roll is 4. Highest roll is 4. Well, this is just the probability that x is equal to 4, which by our formula here is 4 to the 10 minus 3 to the 10 over 6 to the 10. And this is actually about 0.0164. So you can see it's fairly low, which makes sense, since if we roll 6 dice, chances are we're going to get a number that's higher than 4. But yeah, I hope you enjoy this problem, and yeah, I'll hope to see you here next time.